What is going on, everyone? Welcome back to... Oh, what is this? Day 24, last day. We're about almost 40 minutes late here, but that's alright. You know, just cruising into the end. That's what it's all about, getting stuff finished. Click on this one, remember what this was about. So yesterday was about spreading the elves out and planting some stuff. Let's see what 24 has in store for us today. Alright, so Blizzard Basin. Everything replanted for the next year, and the elephants, and with elephants and monkeys to tend the grove, you and the elves leave for the extraction point. Partway up the mountain that shields the grove is a flat open area that serves as an extraction point. It's a bit of a climb, but nothing the expedition can't handle. At least that would normally be true. Now that the mountain is covered in snow, things have become more difficult than elves are used to. The expedition reaches a valley that must be traversed to reach the extraction site. You find that strong turbulent winds are pushing small blizzards of snow and sharp ice around the valley. It's a good thing everyone packed warm clothes. To make it across safely, you'll need to find a way to avoid them. Fortunately, it's easy to see all of this from the entrance of the valley. So you make a map of the valley, your puzzle input. For example, this thing. The walls of the valley are drawn as pound, everything else is ground. Clear ground is a dash. Clear ground, where there is currently no blizzard, is drawn as a period. Otherwise, blizzards are drawn with arrows indicating their direction of motion, up, down, left, or right. The above map includes two blizzards, one moving right and the other moving down. In 1 minute, each blizzard moves one position in the direction it's pointing. Due to the conservation of blizzard energy, blizzard reaches a wall. A new blizzard forms on the opposite side of the valley, moving in the same direction. After another minute, the bottom downward moving blizzard has been replaced with a new downward moving blizzard at the top of the valley instead. Because blizzards are made of tiny snowflakes, they pass right through each other. After another minute, both blizzards temporarily occupy the same position, marked 2. After another minute, the situation resolves itself, giving each blizzard back its personal space. Finally, after yet another minute, do whatever, the process is repeated, at least as long as you're observing it, but probably forever. Here's a more complex example. Your expedition begins in the only non-wall position. Your expedition begins in the only non-wall position in the top row. It needs to reach the only non-wall position in the bottom row. On each minute, you can move up, down, left, or right, or you can wait in place. You and the blizzards act simultaneously and cannot share a position with the blizzard. In the example above, the fastest requires 18 steps. Let's do this example. Okay. Cool. What is the fewest number of minutes required to avoid blizzards and reach the goal? I'm assuming it starts like from the initial state. Okay. So let's just start by parsing some stuff. It's always a good way to start. And okay, and then we'll run this. And we should see how big our input is as well. So this feels like it's gonna be just like a big decision tree. Like the options are kind of like, you can start from the beginning and then basically kind of like create branches at each time where we can do something valid, and then prune them out when we can't. Oh my god. Okay. Okay, I mean, this is a lot of space, but it should still work. Right? Conceptually, it should still work. This is really big, though, so we should make sure that whatever we do is iterative and not recursive. Oop, what the heck? Alright. I think if we're smart about this, I think this maybe isn't going to be too bad, but let's do the first thing, which is... Okay, we parse this. I'm just going to figure out where, like, we enter from, right, which is here. And then I guess we can only go up, down, left, and right, right? Where is this? Okay. Yeah, you can move up, down, left, or right, or wait. Okay. So yeah, let's first get a position. So let's say, let's make a data class blizz, and it's gonna have a it's going to have, we're just gonna make new ones all the time anyways, so we're gonna say location coordinate, and it's going to have a direction coordinate as well. Okay. And then let's, I guess we can do init. Let's actually just read it in. Let's do fun parse input. Okay, so the first thing to do is probably to let's just or start. We can start off it, and then we'll just bound it by like whatever the walls are, since those don't really help us. So start equals line 0 dot get first it equals this, and then we want and we want x of first. How about that? What? Oh, double equals. Okay, and then this one will also be index of first. We don't really care if they're offset at all, so this is fine. We'll just call this 0, and we'll call this whatever that size is, right? So this is actually going to be coordinate xy, and this is going to be the x, and y is going to be this. And then we'll do chord xy of that, and it's going to be lines dot size. All right. And then this should be int, and here we're just going to call parse input. We're just going to work off the test input, since this is going to take a little bit. Okay, and then we're gonna just say start dot debug and end dot debug. Cool. Oh, and let's pull this over here so everyone can see it. All right, so this is 1, and this is 0. 1, 2, 3, 4, 5, 6. Okay, looks good. Oh wait, does not look good. Does not look good. Oop. Last. Okay, try again. Okay, 6, 6, right? 0, 1, 2, 3, 4. Wait, 0, 1, 2, 3. Wrong again. Lines done. Okay. Oh, line numbers here. Got it. So 5, 6. Is that right? And I'm looking down here. This is 6, 7. So that is good because we're working 0 indexed. Okay. So now let's also do var grid. And so what we're gonna do is we're gonna do lines dot, we're gonna drop. This doesn't actually matter. We don't need to drop anything. We're gonna do lines dot flat map. Yeah. And then we're gonna do filter. No. We're gonna do map. Okay, this is actually a pain. I'm just gonna do it var grid equals mutable set of Liz. And then at the end of this, we're gonna return start and grid, I think. So, oop. Triple like that. Okay, and then we're just gonna do a normal for y in lines dot indices for x in lines y. Now we're gonna say if grid dot y. Oh, that's not what we want. We want this to be lines. Dot. Okay, let's just do that. And then if this is a greater than, what do you want? Required in. Oh, I wanted this. It was giving me the actual character, but I want to have the coordinates. So because we're gonna do coord not. Oh, because the blizzards can be going any direction. Oh, jeez. Okay, I don't know if I quite realized that. So actually, we're gonna. That's fine. Actually, coordinate dot xy, and then put those in. But then we also have to say which direction it's going. That's fine. Okay. Here we go. Okay. So that's going right. This is going left. We're gonna do the same kind of confusing thing here. Actually, can I just say say this may be confusing, but I want to actually make it so downward is coordinate dot up. Does that work? Okay, this doesn't really matter, actually. The problem is that this and that, so we're gonna call this down because it's going like negative in our coordinate space, and then that's up. So okay, fine. At the end of this we have our triple, and then we do dot do val start end grid. This just makes it so we don't have issues with I'm just gonna put a print line here. I hate that this kind of wraps over to the side. So okay, so how's this look so far? We have our start and end. We have like this is 1 1, so this is right here, and this should be going to the right, which is column 1, and then 2. That looks good. Going to the right as well, and then we have column 4. This one 4 1 and direction -1 looks good. Going -5. That looks good, and then we want to look for this thing, which is at 4 3. So C equals 4 1 3, right? Oh, sorry. Row equals 4, R equals 4. Column. What? What am I doing wrong? 0 1 2 3 4, and then this should be 0 1 2 3. That's odd. Did I do a capital V? There we go. That would have been horrible. Okay. And now we're going up in our coordinate space. Okay. So what do we want to do here, right? So we're going to say var current position. Hey, what's going on? Is start. And then we're going to say while. This is actually not going to be one spot. This is going to be positions start equal, this is going to be a mutable list. Oop, mustable. Mutable list of coordinates, say. So the reason that we have to do this is that we want to make sure that we're actually tracking all of the spots that we might, or that we'll be at. And then we'll say, wow. Say, well, true. And then we'll, here what to do. Make sure we do an end check. Yeah, I don't actually think, I mean, the question is like, what is the shortest amount of moves? What's the fewest number of minutes required to avoid blizzards and reach the goal? So we don't actually need to keep track of the path. We can just keep track of where we are, and then we'll fan out to any place that we could be, right? And then this shouldn't be too bad. So while we're actually going to do set, and we'll say while current positions, say end, not in. Okay. And then the basic algorithm is going to be for each spot. We'll say update the grid to where it will be for each spot. C add all the spots that we could potentially move. Okay. So let's update the grid. So this isn't too bad. We just say val new grid equals grid, and we will map all of these to be a new blizz, and the location is it.lock. Ooh, I should actually do this. Okay, this is a little bit more annoying. We'll say equals var new lock. Okay, we actually need to know the bounds of our grid, which is just the exterior, right? So say val top left is coordinate xy 0 0, and then bottom right is coordinate xy, and this is going to be lines 0 dot size -1 length, and then this will be lines dot size. Oh, because it's a string. Okay, so let's see. This actually doesn't give us it really, because like we want to know that that's 1 1, and then we'll do like -2 -2, because we want to come in 1 2. So like, all right, let's see what val grid bounds equals. All right, let's do this, and then we'll debug on that. It comes out coordinate range of 1 to 6. So this is x 1 2 3 4 5 6. Seems fine, and then 1 2 3 4 seems good to me. Okay. So then for this new location, is this easy to bound or not really? I guess we could just say if new lock in grid bounds, or we'll say not in grid bounds. And then I don't know. I don't really know how to do this quickly, so we'll just do the checks. If x is less than grid bounds dot range dot first, then we can say, I don't think we can just reassign this, right? So I have to do new lock equals coordinate.xy, and this is going to be, so if it's all right, so that would set it back over here. Else, if this is greater than last, because these are inclusive, we can just do set it as first, and then we can do this but with y, right? So if y range greater than y dot last, then we will we'll keep the x and go to the y range dot first, and then let's do this. Okay. And since it's only traveling in one direction at a time, it can't be these are all mutually exclusive. So this puts everything in bounds, and then we can make our Blizz new lock it dot dir. Okay, cool, that's updated. And then for each spot, I should just double check this. So if x is less than first, if x is greater than last, it's less than first, set it to last. X is greater than last, set it to x range dot first. Okay. All these are y range. Y is less than y range first, set it to y range last. X here, y is greater than last, set it to first. Okay. Okay, now what we want to do is we're going to say val new possible locations equals. All right, so we are going to say current positions dot map. This has to be a flat map actually. So flat map means I'm going to give it maybe more than one, and you need to keep all of them. So val new positions equals list of coordinate. All right, so now we just go through the options, right? So return new positions, or I guess it's not a return, but okay. If it not in new grid, so this is oh, it's kind of annoying actually that these are okay. Val new map equals new grid dot map it dot location to set. Okay. So new positions add, okay, so this is like stay still. Okay, and then we can do it dot we're gonna do neighbors bounded, and we're gonna give it the grid range that we already have, right? So grid bounds dot xrange. This is the utility class that I made, and then we can give it the plus, which means check up, down, left, and right. So we'll call this possible moves. Actually, we don't even need that. Honestly, this comes back. We're just gonna filter these for it not in new maps. That means it's not occupied by Blizzard. And then we're just gonna add all these too. Since we'll just do the weird thing, which is for each. Add it. Don't worry about it. Okay. New possible locations. And so then this is going to be to set because we want to dedupe all those. And then what we're going to do is we're going to replace the current positions. So basically we're going to replace both of these. So, oh, this is working out good. I'm going to call this val current grid equals mutable set of. I really freaking hope this works the first time. Dot add all. Okay. And this is going to work off of this. Yeah, I hope this works. Okay, so at the end of this, we're going to say current grid.clear, current grid.add all. New grid, and then we'll say the same thing for current positions dot clear, current positions dot add all. There's definitely other ways to do this, but this is what we're doing right now. This actually is not gonna pick up. This will not pick up moving to the final spot. So we will also say we need to do pre-end equals n n plus down. Let's debug this and make sure this is what I think it is. Pre-end equals. Wait, are we running right now? Type mismatch. What to do? Oh, okay. So if end equals pre-end, then we can probably actually just we can actually just return here. If we're in the spot that we can move from here to the end, then this is. So here I'm actually just going to say var round count equals 1. I think that's how they labeled it. Initial state 1 minute is after that move. So yeah. So I'm just gonna do this. I'll do this plus 1. I think this might even be. It's supposed to be this. I don't know. We'll see. See what happens. Is that right? I think so, actually. Right? 18? Nice. Okay. Okay. Sweet. As the expedition reaches the far side of the valley, one of the elves looks especially dismayed. He forgot his snacks at the entrance to the valley. Since you're so good at dodging blizzards, the elves humbly request that you go back for his snacks from the same initial conditions. How quickly can you make it from the start to the goal, back to the start, then back to the goal? In the example, the first trip to the goal takes 18 minutes. The trip back takes 23 minutes. Okay. Okay. So this is fine. I'm gonna copy all this. Never wanted that anyways. Okay, so part 2. The reason I'm copying this, it really doesn't like that I took. I guess it's not clear that it'll ever get there, so return 0. I'll just say throw run. Oops. Okay. It's my favorite error handling. So this is fine. We can just when we get here, we're just going to hold on a sec. Okay, this is fine. We can do all this. And then here we're going to say is if we want to look at the old location. So if the current positions, if pre-end, I know, what a great name, is there, then okay, this is going to be an else. Okay, so else. Hold on a sec. Okay. So else we want to do that. Right? Calculate all the places we should go. If we are in pre-end, then we want to move to the new spot. So we have to move into the final. So we're going to say we're going to do this, and then we're going to do we're going to add exactly one spot, and that spot is end. And then we're going to say long. Okay. Boolean var hit end equals false. Var back to start equals false. Okay, so hit end. Okay, if pre-end and either not hit n or back to start. So we've gone back to the start, or we haven't got to the end, the first. Then move here, and then we'll say is if back to start, we'll return round count plus 1. Not too long. What do you want? It's fine. Okay. Otherwise, we're gonna say n equals true. And then this will send us back to the beginning. And then we also need like a pre-start is start dot start plus up. Yeah, that's fine. Okay. And then we'll, okay, so this says if we're one in front of the end and either we have gone back to the start already or we actually haven't. And not end or start. Okay, that seems right. Okay, else. Okay, pre-start is in one of the current positions, and we've hit the end, and not back to start. So this means we're headed back to the start. Then we're going to say back to start is true, and then we're gonna put the only place that we are at is start. This code is a little jank. Should work. What am I missing? What am I missing? This is moving our current position. So end. Start. It's good. It's good. Why do we just have an extra bracket here? I don't like this. Okay, seems kind of fine. No, that's not fine. I just deleted a thing and I don't really know. Okay. What the hell? What did I do? Sec. Sorry about this. Okay, I don't know how I just deleted that, but no worries, no worries. Okay. So we are looking for 54 minutes. So let's just put that here, 54 long. Don't need this. If it works, keep running the second part. Let's do it. Come on, come on, come on, come on, come on, come on. Go, go. Oops. Is that really the condition I had before? I think that's just so sweet. True. Okay. It means I got the right answer on the other part. Nice. That was awesome. That was like, that felt pretty, I don't know, that felt pretty good. Check it out. Yeah. So we were just over 1,000. And what I say, I think we started, we've only been going for 45 minutes. So, yeah, I mean, started half-hour late or so, and I think we did quite well on that, actually. The best times were in the 20-odd minutes, so yeah. I'll say I rather like that day. Happy to be done with the blizzards. And not much else to say here. So, day 24 done. We'll come back tomorrow for day 25. Wrap up Advent Code 2022. You will be there. See you tomorrow.